Let's take a look at this example. How I would supposed to solve this problem. First of all, I would recommend to redraw this circuit. Okay, so let me just make this point A, and this is my point B. So what I'm going to do right now, I'm going to simply draw the voltage source, and this is my point A, and this is my point B. Please notice that resistor R1 is connected directly across my voltage source. So I'm going to draw over here my resistor R1. Okay, R1 is connected to point A and point B, right? Next, please notice that I have resistor R2 connected to point A as well. Okay, so I'm going to have my R2 over here, and R2 is connected also to what? To R3, and R3 is connected to point B. By the way, this is my ground also. Okay, so this is my resistor R2, and this is my resistor R3. Please also notice that this is my node, right? This is like one point. Point A is connected to resistor R4. This is my resistor R4, and R4 is connected to resistor R5. This is my R5, and R5 is connected to resistor R2 to the junction, right, where R2 and R3 are connected together. So I'm going to make something like this. Okay, so this is the same circuit, right? But I believe that this picture is looking much simpler than this one, because over here we can see that these two resistors are in series and in parallel with this one. Okay, and after that we can see that these three are in series with this one, and those four are in parallel with this one. So what I'm going to do right now, I'm going to find the total resistance for these four resistors. Okay, so these two resistors are in series. That's why I'm going to find R4 5 is equal R4 plus R5. R4 is equal 3 kilo ohms plus 5 kilo ohms. This is equal 8 kilo ohms. Okay, so I found the equivalent resistance for these two. So I can redraw the circuit, and my circuit is going to look like this right now. This is my R1, this is my R2, this is my R4 5, and this is my R3, and this is my ground. So as you can see, these two resistors are in parallel. Okay, they are in parallel, so I have R2, 4, 5. Because I have just two resistors, I'm going to use the product over the sum. R2 times R4, 5 over R2 plus R4, 5. R2 is equal 1K times R4, 5 is equal 8K over 1K plus 8K. And this is equal 1 exponent 3 times 8 exponent 3 equals, divide by open parenthesis, 1k plus 8k is 9k, equals 888.88 ohms. Okay, this is the equivalent resistance for these two resistors. Okay, so I can redraw the circuit one more time. Redraw my circuit one more time. This is my voltage source. And this is my R1. And I have right now my R2, 4, 5. And this is R3. So as you can see, these two resistors are in series, so I can find the equivalent resistance for these two. So I have R2 to 5, we can say, right, is equal R2 4 5 plus R3. R2 4 5 is equal 888.88 ohms plus R3, which is equal 3k. So R2 5 is equal 3.88k. So this is my equivalent resistance for these two resistors. And again, I can redraw the circuit. This is my R1, and this is my, of course, this is my ground. This is my ground, and this is resistor R2 to 5. Okay, so this resistor represents these four combined together. Next, we can find the current which goes through resistor R1, and we can find the current which goes through resistor R25. So we have I1 is equal voltage source over R1. I'm using Ohm's law. So voltage source is equal 9 volts over R1, which is equal 2k. Okay, and we have 9 divided by 2 exponent 3. This is a very simple calculation, but let's practice the calculator. So I have 4.5 milliamps. So this is the current which will flow through the resistor R1. Next, I can find I2 to 5. It means the current which will go through these four resistors, right? So this is my I2 to 5. So I2 to 5 is equal voltage source over R2 to 5. So this is equal 9 volts divided by 3.88k. This is equal 9 divided by 3.88 exponent 3. This is equal 2.32 milliamps. Now please notice that we found current I1, and we found this current. Okay, so this is my I2 to 5, and this is my I1. If you are going to use KCL, you can find I total, or we can say I source. I source is equal I1 plus I2 5. I1 we found is equal 4.5 milliamps plus I2 to 5 is equal 2.32 milliamps. So if I source is equal, very simple calculation, right? So if 2 plus 4 is 6, and we have 0.5 plus 0.32 is equal 0.82 milliamps. So I have 6.82 milliamps. So this is my I source. Next we're supposed to find the current which goes through resistor R2. Okay, I have to find current which goes through the resistor R2. I'm going to use this circuit because this time I want to use the current divider rule. Okay, this is parallel circuit, so parallel circuit will divide the current. I have found already current I2 to 5. Okay, so this is going to be the current which is going to split into these two currents, and I have the values of these two resistors, so I can use current divider rule, and I believe this is the simplest way to get current I2. So I can write that I2 is equal I2 to 5 times equivalent resistance R245 over R2. So this is equal I2 to 5 is equal 2.32 milliamps times R245 is equal 888.88 ohms over R2. R2 is equal 1 kilo. So this is equal. Okay, so we have 2.32 milliamps, 2.32 exponent 3 negative times 888.88 divided by 1 exponent 3. This is equal 2.06 milliamps. Okay, so this is the current which will flow through the resistor R2. So we found I2. If you want to find the current which flows through the resistor R3, you're supposed to realize this is the same current which will go into all these three resistors together. Okay, I mean, you know, if we found I2 5, right, this is going to be the same current over here, because this current is going to split into two currents and is going to get back at this point and is going to form I3. So I can say that I2 5 is equal also to I3. Okay, and this is equal 2.32 milliamps. Okay, so we found I3. So next we're supposed to find I4. I4 is the current which will go through resistor R4. Again, I'm going to get back to this circuit, okay, where we have the equivalent resistance to these two, and simply, basically, we can use also this one, because we know current I2 already. We know current I25, so I25 minus I2 will give me this current. Okay, the current in resistor R4 is going to be equal to the current at resistor R5 because they are in series. So this current minus this current will give me this current. So I have I4 is equal I25 minus I2. And this is going to be also equal to I5. So I25 is equal to 2.32 milliamps minus I2, and I2 is equal to 2.06 milliamps. This is equal 2.32 exponent 3 negative minus 2.06 exponent 3 negative equals 260 microamps. Okay, so this is my current I4. Now we're supposed to find Vx, Vzy, and P5. By the way, we found I4 already. So Vx is the voltage at this point. Okay, this is the voltage between these two resistors. Okay, so this is the voltage from this point to ground. From this point to ground. So what we can do in order to find this voltage, we can simply find voltage across this resistor. We can find V4 because we found already I4. Okay, so V4 is equal I4 times R4. I4 is equal 260 microamps times R4, which is equal 3 kiloohms. So this is equal 260 exponent 6 negative times 3 exponent 3 is equal 780 millivolts. 780 millivolts. This is my voltage at resistor V4. So in order to find Vx, okay, this is my X over here, Vx, I'm going to simply subtract from my voltage source, I'm going to subtract V4, and I'm going to have this voltage. Okay, so this is like this is my voltage source, and this is my V4. Voltage source minus V4 will give me Vx. Okay, so I'm going to simply write Vx is equal voltage source minus V4. Voltage source is equal 9 volts minus 780 millivolts is equal 9 minus 780 exponent 3 negative equals 8.22 volts. 8.22 volts. Next we're supposed to find Vy. Okay, Vy is the voltage at resistor R1, okay, because if you are going to measure the voltage between this point and ground, this is nothing else just the voltage across resistor R1. Okay, so we found already I1. Okay, so let me write this down. Vy is equal V1. And if you want to find voltage at resistor R1, this is basically nothing else, just what? Voltage source, right? V1 is equal to voltage source because this resistor is connected directly, right? Directly across the voltage source. So V1 is equal 9 volts. Okay, so we found Vy. Next we're supposed to find Vz. Vz is the voltage from this point to ground. So this is the voltage across resistor R3. Okay, so voltage across resistor R3. This is this voltage. Okay, we found the current which goes through this resistor. We said that I25 is equal to what? I3, which says so because this current is going to split and is going to divide itself into I2 and I45, and after that it's going to come together again and form I3. So this current is equal to this current. So if I know this current and I know the resistance, I can find the voltage 3. So I can say that Vz is equal V3, and this is equal I3 times R3, where I3 is equal I25, so this is equal 2.32 milliamps times R3, which is equal 3 coulombs, and this is equal 2.32 exponent 3 negative times 3 exponent 3 equals 6.96 volts. 6.96 volts. So we found Vx, we found Vy, we found Vz. So now we can find Vzy. Vzy is equal Vz minus Vy, where Vz is equal 6.96 volts minus Vy, which is equal 9 volts. Okay, we don't need this Vz over here. So we have Vzy is equal 6.96 minus 9 is equal negative 2.04 volts. Okay, this is my Vzy. Next we're supposed to find P5. Supposed to find the power at resistor R5. So this is my R5. We found already current which goes through resistor R4, right? We said that I4 is also equal to what? I5, and is equal to 60 microamps. So if I know the current which goes through resistor R5 and I know the resistance of resistor R5, I can find the power. So P5 is equal I5 square times R5. I5 is equal 260 microamps to the second power times R5, which is equal 5K. So P5 is equal 260 exponent 6 negative to the second power times 5 exponent 3. This is equal 338 microwatts. So as you can see, okay, we've found all currents, we've found all voltages, and we've found the power, so we can say that the problem is finished.